Good morning, chemistry students. Today's lesson we are focusing on primarily standard B, where we are looking at the fact that the proton is the identity of the element. We're also going to be looking at the position of protons, neutrons, and electrons, as well as how to determine the number of protons, neutrons, and electrons for an element, an ion, as well as an isotope. Oops, here we go. So, starting with just kind of a quick summary of each of our subatomic particles. For an electron, its symbol or its abbreviation is an E with a little minus sign. It, of course, has a negative charge and it lives in the electron cloud. It takes almost 2,000 electrons to equal the mass of one proton. Technically, it is exactly 1,840, but they're really, 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 really small and they live outside the nucleus. Our protons, its symbol is a P with a little plus sign. Protons are positively charged and they have a mass of 1 AMU. AMU stands for atomic mass unit. Atomic mass unit is actually how we measure the masses of subatomic particles. Not that you're going to be asked this, but if you're curious, AMUs are based off of the mass of carbon-12. It is defined as 1/12 the mass of the carbon-12 atom. Now, your protons live in the nucleus with the neutrons. Neutrons, their symbol is an N with a little zero symbol indicating that they have a neutral charge. Neutrons and protons have the same mass. They have essentially identical masses, so they are equal in mass, but only the proton has a charge. They both live in the nucleus, and then our electrons who live in the cloud have that negative charge. Now, when you're looking at an atom of a single element, all of the atoms of the same element are going to have the same number of protons. That proton, as our standard says, is the identity of the element. Now, we are going to assume for the most part, unless told otherwise, that the atom is neutral. And since it is neutral, my number of positives have to equal my number of negatives. So for our neutral atoms, the number of protons ends up equaling the number of electrons. Now, the neutrons are the thing that helps contribute to the mass. So the neutrons and the protons make up the mass. So if I give you your neutrons and your protons, all you would need to do is add them together to get your atomic mass, or sometimes it's just called mass number. Now, if you're trying to determine some of the following information, to get your protons, you just look at that atomic number. To determine the number of electrons, if it's a neutral element, you also look at the atomic number. If it's a neutron, we're trying to figure out what we're going to do is we're going to take that mass number or that average atomic mass and we're going to round it to a whole number and then subtract from it the atomic number. Now, if you look at your periodic tables, whether it be the real periodic table or the fictional periodic table, they both have the same general layout. The number that is at the top is the atomic number. I'm going to pick on element number 17 on the fictional periodic table. So element number 17 has 17 protons, 17 electrons. Its symbol is C. C, its name according to the fictional table is calculon. And its mass happens to be exactly 37.00. Yes, there's this little number in the bottom right-hand corner, but we're not going to really pay much attention to that at the moment. That is their electronegativity value. We won't really need that till we get into trends and into bonding. So on my periodic table, if I was a student, I would probably out to that key at the top write myself a love note that this number on the top always equals my number of protons. And that this number on the bottom, to get my neutrons, I take the mass minus the atomic number. Now, if the element is neutral, my protons also equal my electrons. So for these first couple examples, we are dealing with neutral elements. So for example, with our real periodic table, notice on the screen I've got boron's information. So I can see that boron would have 5 protons, it would have 5 electrons, and 10.8, so 10.8 would round up to 11. So to figure out my neutrons, I would take 11 minus 5, and my neutrons equal 6. Neutrons are going to always have to be a whole number. You can't have a part of a proton or a part of a neutron. So if you're rounding, remember your rounding rules that you learned back in, I think, middle school. If it's 5 or more, you round it up. If it's 4 or less, you let it rest. So if I happen to have like a 9.4, it would stay a 9. But if I had a 9.5 or a 9.6, it would round up to a 10. So using your real periodic table, don't know why it's not working. There we go. Determine the number of protons, neutrons, and electrons for both chlorine and tin. And for those of you who are playing with the online version of the periodic table, there is a nice, neat shortcut for finding elements quickly on your periodic table. I'm going to show you real quick. There we go. So like I said, I wanted you to find the number of protons, neutrons, and electrons for chlorine and tin. So I've brought up the PDF copy of our periodic table that's in Google Classroom. And when you have it up, if you hit Control F on your Chromebook, or if you're on a MacBook or an iProduct, I think it's Command F, but Control F brings up this little box for you to find something. You can type in what it is you're wanting to look for. So we know that we are wanting to look for chlorine, CHLORINE. And I hit enter. I don't technically even have to type in the whole thing, but it will jump to that and it will highlight on the screen. So I can easily see that chlorine's atomic number is 17 and its average atomic mass is 35.45. So that would round to 35. Going back to answer our questions. For chlorine, its number of electrons is 17. God, I love that this isn't doing it in order. Its number of protons are also going to be 17. And its neutrons are going to be whatever 35 minus 17 equals. And handy dandy calculator, 35 minus 17. So it's going to be 18. That's going to be my neutrons. So rinse and repeat for 10. 10 is one of those where its name does not match its symbol. So it's always fun to find. Control F and type 10, T-I-N. And it says that there's one of 6. So notice that it automatically highlights element number 50. I can kind of zoom in and you can see it. If it wasn't on the screen, when I hit enter, it would jump to that first one. Oops. There we go. So SN is element number 50. Its average atomic mass is 118.69. So 0.69 is bigger than 0.5. 5 or more raised the score. So 118 is going to round to 119. So in terms of my protons, neutrons, and electrons, my protons is that atomic number, which is 50. My electrons is the atomic number because this is neutral, which is 50. And now it decides to work properly. And my neutrons are going to be that mass minus atomic number. So 119 minus 50. Doesn't matter whether it's the real elements or the fictional elements, they all work exactly the same. The atomic mass is my protons plus my neutrons. Atomic number is my protons, always and forever. So pause the video here and take a moment to try and do these fictional elements, see if you can determine and fill in the charts for them. Now, I did pick on just a few of the fictional elements, focusing on just one part of the periodic table, so I wouldn't have to kind of alternate between 2 slides. but it's telling me its rounded atomic mass is 75. So I'm looking at my masses. Well, I've got 71.6, 74.9, and 78. That means this first one has to be this element, which is symbol A. Its atomic number, I'm just filling the information in from the periodic table. So the atomic number is always going to equal my protons. Always, always, always. If the element is neutral, it's also going to equal my electrons. So my neutrons, I'm going to take that 75 minus 33 gives me 42 if my mental math is correct. Looking at the second one, protons is 31. That means it is playing with element number 31. So element 31, its symbol is G. Its atomic number is 31. Its mass 68.0, rounds to 68. Neutrons, I take that 68 minus 31 equals 37. And electrons equals protons because it is neutral. So element number 13, that's this one up here. Atomic number and my number of protons are the same thing. So upper letter A, lower letter F. These symbols, we are talking in codes, we're talking in abbreviations, and it is important that that first letter be uppercase and that second letter be lowercase. So it's rounded mass, 25.4, rounds to 25. Protons is 13, electrons is 13, neutrons is 25 minus 13, so 12. So notice your neutrons don't always equals your protons. Sometimes they do, especially for some of the smaller elements, but that is not an always sort of thing. All right, last example, we're looking at ST. Well, it means we are looking at element number 34. So its atomic number is 34. Its mass rounds to 79. 34 protons, 34 electrons, and whatever 79 minus 34 for my neutrons. And no, you don't necessarily have to write that subtraction piece. I'm just doing it so you can get an idea of where those numbers are coming from. So that is our normal elements, but not all elements are normal elements. Some of them are isotopes or ions. Alrighty, so what is an isotope? What is an ion? Well, an isotope is an element that has a different number of neutrons. Since it has a different number of neutrons, it has a different mass. There is one of 4 different ways that we illustrate or indicate that we have an isotope. H-2, the symbol dash its mass is one of the common ones, and the other more common one is using the mass in front of the symbol. The number that's given to you is the mass. It is telling you that, hey, this hydrogen has a mass of 2. If it's got a mass of 2, that means there is going to be a neutron with it that it doesn't normally have. Now, an ion is an element that has gained or lost electrons. The way we indicate that an element has gained or lost an electron is by showing that charge as an exponent. So positive charges means that we have lost electrons. Negative charges mean that we have gained electrons because electrons are negative. So if I put more on me, I'm going to be negative. If I give some away, I'm going to be positive. Now, the way we determine protons, neutrons, and electrons for isotopes and ions is really similar for elements, for normal atoms. Protons is always the same. Proton is atomic number. Electrons get a little tricky. We're going to look at some specific examples, but I am starting with isotopes. So isotope has a different mass. So an example of an isotope would be example carbon-14. This is a real isotope of carbon. It is actually what's used in carbon dating. It's how we tell how old dinosaur bones are and old ceramic palettes and stuff like that. Carbon 14 has a mass of 14. The reason it has a mass of 14 is because it has 2 more neutrons than our normal carbon, which is carbon 12. Boron 12, so notice normal boron, its mass rounds to 11, so boron 12 has 1 extra neutron. Now, it is important to note that if I ever give you the number of neutrons in a problem, just assume it's an isotope. Assume it's an isotope until you add the protons and the electrons together and see if the matches what's on the periodic table. If it does match, it's not an isotope, but if it doesn't match, then it is an isotope. So you're better just kind of err on the side of caution if I give you neutrons. So let's look at a couple examples, and yes, this is using the real periodic table, and I'm going to do them a little bit out of order. Don't know why, I just kind of feel like it. So starting with D and E, notice I'm giving you their masses. So I could say 60U dash, that's not a minus sign, that's a dash. 60U dash 65 is the same thing as saying 65 as an exponent in front, and then Cu. Same thing with my hydrogen 2. So my number of protons. Protons equals atomic number. So I'm looking at my real periodic table and I'm looking for Cu. It is element number 29. That means it has 29 protons and 29 electrons. My neutrons. This is the only thing that's different. Don't use the mass from the table. Never ever use the mass from the table for an isotope. You've got to use the mass that's given to you. So I'm going to take my 65 minus my 29, and I am going to get, fudge sauce. 69 minus 65 minus 29 gives me 36. See, I should have went with my first instinct. So it has 36 neutrons. We look at the periodic table. Normal copper or normal atomic copper has an average mass of 64. So this one has 1 extra neutron. Hydrogen 2. So again, I'm going to take its atomic number and subtract it from the mass. So 2 minus 1 gives me 1. Hydrogen 2 has 1 neutron, where normal hydrogen has none. But no matter what type of hydrogen it is, they all have 1 proton and 1 electron. So the other 3, you're kind of working backwards. You're trying to determine what type of isotope, or if it's an isotope, from the information that's given. So my proton determines the identity. That proton is going to tell me its symbol. So with having 17 protons, that means we're working with element chlorine. Well, chlorine has a mass of 35.45, so basically 35. So 17 plus 18 gives me 35. This first chlorine is normal chlorine. Yes, you could specify that it has a mass of 35, but this is our normal atomic chlorine. The second one, who has a mass of 37, wait, 17 and 18, is that 35? Yes, 17 plus 18. Gotta get used to doing mental math again. So for the second one, 17 plus 18, protons, 17 plus 20, protons plus neutrons tells me that this chlorine is an isotope. It is isotope 37. It has a different mass because it has a different number of neutrons. All right, looking at the last one, C, 19 protons. 19 protons means we are looking at potassium. Its symbol is a K. 19 plus 21 gives me a mass of 40. So this is potassium 40. This is an isotope of potassium because its mass does not match what's on the periodic table, or at least a rounded version of what's on the periodic table. Again, if I give you the neutrons, assume it's an isotope. Add them together and check it against the table. If I give you the mass with the symbol, use that number. Always use that number if I give you that mass. So for our ions, like I said, are an element that has gained or lost electrons. It's important to note that metals are going to always lose electrons. They're going to always give them away, and they're going to form what we call a cation. So that T kind of can help remind you that that cation has a positive charge. Our nonmetals always go out and steal electrons, and when they steal electrons, they form a negative ion that we call an anion. So a negative ion, can kind of use the name to help you remember that anions are a negative ion. Now, as I said earlier, ions, we always show their charge as an exponent after the symbol. You have to include that positive or negative to indicate exactly what is going on. But to determine protons, protons is always the same. It's the atomic number. Neutrons is mass minus number. The only way it gets a little bit tricky is when you're starting to try and find your electrons. So, a metal will always have a positive charge because it lost electrons. So if we see a positive ion, we've got to subtract the number. So whatever that charge is, you've got to subtract it from your protons to determine the number of electrons. If you've got a negative ion, you've got to add that number to your number of protons to determine the exact number of electrons. So the math is a little bit opposite. Because we are dealing with negative things, if I give away negative things, I become positive. If I steal negative things, I become negative. So let's look at a couple of examples. And I'm going to kind of rush through the whole proton and neutron part because it's the same as what we saw at the beginning. Neutrons is mass minus number, protons is atomic number. So the only thing that gets a little bit tricky is our electrons. So I've got Ca plus 2. Plus 2 means I lost 2 electrons, so I've got to subtract. So normally calcium would have 20 electrons, but this one has lost 2, therefore it only has 18. Bromine and ion, that negative ion means that we have gained 1 electron. We go out and we gain 1 electron. Well, I got to take 35 and I got to add 1 to it, so it has 36 electrons. Aluminum plus 3 means we have lost 3 electrons. That would be something that you are more than welcome to write on your periodic table. Positive charge means subtract, means I gave them away. So normally aluminum would have 10, but this aluminum ion, bad misreads. Normally aluminum would have 13, but this ion of aluminum has 10. And last but not least, I've got iodine, negative 1. Well, iodine normally has 53 electrons. That negative 1 means it has went out and gained 1 electron. Therefore, it has 54 electrons. So that is our ions. In terms of having to determine the number of subatomic particles, I would say that they're probably the trickiest. And you want to make certain you take your time and look at and ask yourself, am I gaining electrons or am I losing electrons? So instead of me giving you the symbol, what if I'm asking you for the symbol? Well, to determine the symbol, you use your protons. To determine the charge, you see what you have more of. So looking at this, my real periodic table says we're looking with 38 protons. Element number 38 is strontium. And notice how strontium has 2 more protons than electrons. So since it has more positive charges, it is strontium plus 2. It is a strontium cation. Looking at the second one, element number 15 is phosphorus. Well, phosphorus has more electrons. It has 3 more electrons. Therefore, this is going to be phosphorus minus 3. Looking at that third one, element number 34 is selenium Se. Selenium has 2 extra electrons. It is a selenium anion, so it's Se minus 2. Last but definitely not least, protons are 20, so we are looking at calcium, and calcium has more protons than electrons, so it is calcium plus 2. So you can kind of see you can go either way. You can go from the symbol to the electrons or from the electrons to the symbol. And no, you're not going to see isotopes and ions combined. We don't typically combine them for first year chem. So yay, it's only going to be an atom, an ion, or an isotope. So real quick summary, when you're trying to determine your subatomic particles, that atomic number is the identity. That atomic number determines the number of protons. The atomic mass is your sum of protons and neutrons. And electrons are a negative charge, and they can be gained or lost to form your ions. So that negative ion means we have gained, so we have to add the number. A positive ion means you have lost, so you have to subtract. I'm going to actually write the word add. So that is it. You are going to start your atomic structure practice. If you run into any challenges, definitely hit me up in our open office hours or schedule yourself for a one-on-one tutorial.